Question 1. They want us to compute 8 factorial. The definition of 8 factorial is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Using our TI-83 calculator, we enter 8, math, probability, we look for the factorial key, enter 40,320. Question 3. They want us to compute 6p5. By definition, that's 6 factorial over the difference between 6 and 5 factorial, which is 6 factorial over 1 factorial. 1 factorial is the value 1, so the answer is really 6 factorial. Now, we can enter in our TI calculator 6 math PRB factorial and the answer is going to be 720. However, note that we could have entered 6 math probability permutation 5 for 6p5, and we also get 720. Question 5. They want us to compute 28C1, which is 28 factorial over 1 factorial times the difference between 28 and 1 factorial. You get 28 factorial. 1 factorial is 1 over 27 factorial. Now, what happens here, using definition of factorial, in our numerator, we get 28 times 27 all the way down to 2 times 1 for 28 factorial. In the denominator, I get 27 times 26 all the way down to 2 times 1. By the cancellation property, we're left with the single value of 28. So 28C1 is 28. Using our TI calculator, we're going to enter 28 math probability combination 1, and we find the answer is 28. Question 7. Question 7. The library is to be given 7 books as a gift. The books will be selected from a list of 19 titles. The books you're selecting all have to be different. So if you have a pool of 19 books and you're selecting 7 different books, that means that this is either a combination or a permutation. Now all they require is that the book just be different. There's no information about us caring about the order. So we don't care about the order here. This is a combination. 19C7. Entering this in the TI calculator, 19 combination, 7, we find that there's 50,388 arrangements of 7 books where we don't care about the order. Question 9. Question 9 is a lottery problem where there's a pool of 21 numbers and you need to select 6 numbers. They want to know how many sequences of 6 numbers are possible so that we can answer a probability question regarding winning this lottery. Now, lotteries, you don't care about the order. So since the numbers are different, this is either a combination or a permutation. We don't care about the order. That makes this a combination problem. This will give us the total number of sequences of 6 numbers taken from a pool of 21 numbers. Using our TI calculator, 21C6, we find there's 54,264 numbers. I should say 54,264 sequences of 6 numbers, in which one of those sequences is the winning sequence. So what that means is the probability of winning this lottery is 1 over 54,264. Question 11. Question 11 consists of selecting 5 people to participate in a show taken from a pool of 28 people. Now, when you select people, they don't have any sort of indication as to any sort of responsibilities here. We don't care about the order of the 5 people we're selecting, so we're going to select 5 different people where we don't care about the order, and this is a combination. It is 28C5. Take 28, look for your combination key, hit enter, and we find that there's 98,280 arrangements of 5 people taken from a pool of 28. Now, in question 11, they want to know what's the probability that you select the 5 youngest people. Well, there's only one list, only one arrangement of 5 out of the 98,280 that will consist of the youngest 5. So that the probability of you selecting that particular list is 1 over the 98,280. Question 13. Question 13, you have a pool of 8 people in which you're going to select 6 to somehow stand or be arranged in a straight line. I'm going to admit to you this is somewhat of a strange question that I'm not quite sure what they mean about having a straight line. But what I can read into this is that these are 6 different people from a pool of 8, which makes this a combination or a permutation. The fact that they require this line to be straight, to me, indicates that they somehow care about this order, which makes this a permutation. So this will be 8p6, because we care about the order. Using our calculator, 8 probability permutation 6, we find 20,160. There's 20,160 arrangements of 6 people where you care about the order, and they were taken from a pool of 8 people. Question 15. A pollster wants to minimize the effect the order of questions has in a person's response to a survey. How many different surveys are required to cover all possible arrangements if there are 6 questions on the survey? So, if there are 6 questions on a survey, and they're going to select all 6 of those questions, obviously they're different questions, so this is either a combination or a permutation. Now, somehow they want to minimize the effect that the order has on these questions. In other words, the order is affecting, the order of the questions is affecting the pollsters. So to minimize this, that means they care about the order, which makes this a permutation. You care about the order. So we're going to compute 6p6. We could go to our TI, 6, math, probability, permutation, 6, enter, and we find the answer is 720. Question 17. Question 17. A tourist in France wants to visit 12 different cities. How many different routes are possible? This is a classic route problem that we've talked about. Well, if there's 12 different cities, we can use the multiplication rule. And we can say, for the first stop, there's 12 locations we can visit. For the second stop, there'll be 11. For the third, 10, because once you went to a location, you don't go back to that location. All the way down to you finish every stop. So the answer here will be 12 factorial. 12 math PRB factorial, and we find this huge number. We'll figure out what this number is. 479 followed by 2 zeros, 16 followed by 2 zeros. Looks to me like there's 479,001,600 routes. Question 19. Question 19 says you have a certain lottery where you're going to select a sequence of 5 numbers from a pool of 31 numbers. So usually this would be 31C5. But in this problem, It's a different type of lottery. What they say, to win the lottery, a person must select the correct 5 numbers. Okay, that hasn't changed. But what has changed is that they have to select the numbers in the same order in which they are drawn. What that means is order is important, and you care about the order here. This makes this a permutation. So that the total number of sequences of 5 numbers taken from a pool of 31 numbers, where you actually care about the order, makes this a permutation problem. We're going to find 31p5. We'll figure out this number. 20389 320. That means there's 20,389,320 sequences of 5 numbers where you care about the order taken from a pool of 31 numbers. Now, yet again, of all these numbers, or all these sequences of 5, there is only one winning sequence, which means the probability of winning becomes 1 over that 20,389,320.